Hello everybody. This video is going to be some extra practice with function stories that we've done in class recently. More specifically, distance versus time graphs and speed versus time graphs. So the very first thing we want to do anytime you're dealing with any type of, they're called like function stories or any type of real world graph, as we noted in class, you want to check out the axes that you're dealing with. This is going to change the context of what you're dealing with, even though they may look very similar. Depending on what that y-axis is labeled with is greatly going to change how you do the problem, what different things mean. So in this case, with this practice question, we're looking at distance from your house in meters. This is someone, let's say, traveling to work. So Odell is going to work. During which interval was he traveling at the fastest speed? Okay, anytime we have to decipher something like this with a distance graph, when were you moving the fastest, when were you traveling the quickest, anything phrased like that, it's basically a fancy way of saying find the greatest slope in the graph. Okay? So this can be done visually if we have something as accurate as this where we can clearly see the lines. As you know too, with slope, you can do rise or run to figure out which of these segments has the greatest slope. So if we were to do some calculations here, from A to B, this interval right here, we had a y difference of 100 meters and a time difference of 50 seconds, so 100 over 50 would be a slope of 2 units, which you can also see just like I said by visually looking at the line. But this would be a slope of 2 units, meaning that she's traveling at 2 meters per second at this interval. Okay, the next interval from B to C. She's returning home, goes back really quick to pick something up. Just because it's going down doesn't necessarily mean she's moving slower. We still have to figure out the slope here. So we're going from 100 meters to 40. So that would be a vertical distance of 60, or vertical change of 60. And our horizontal change, our x, or our run in this case, would be from 50 to 70, which is a difference of 20. So that would be 3 meters per second when he goes into 60 3 times. And last but not least, CD. Okay, CD at the end here. Our vertical change is 40 to 160, which is 120. And our horizontal change is from 70 to 100, which is 30, meaning this has a slope of 4. She's traveling 4 meters per second. Remember, slope represents rate of change. So in this case, the rate of change is speed. So she's moving at different speeds at each of these intervals. And we're not going to take DE into consideration. Why? Because she's not moving at all. That represents her sitting at a traffic light or pausing. Him, in this case, Odell. We'll talk about that one in a second. So in this case, when was Odell traveling at the fastest speed? In the interval CD. Okay, so anytime you see something with speed, when there's something moving the fastest, someone moving the fastest, think about slope. You don't just try to eyeball it. If you look at this one, A, B, and CD are kind of close. If you're just looking at it, you might have to actually calculate it, which in that case, it's, like I said, change in x, 2. Change in y divided by change in x. Rise over run. Okay, and number 2, what could possibly be occurring in the DE interval? Because distance isn't changing and time is passing, you're staying in the same spot. So you could be resting, pausing, at a stoplight, stop to take a break. Basically anything where you're not moving. Okay. A different graph might involve the label of speed on the y-axis. This is going to be a little bit different. So again, we're going to take a look at some practice questions just to help. We're going to first identify where was Odell not moving? Where was he not moving? Since this is speed, the number one mistake that we see here, people look for the horizontal lines. But if you look at this first one right here, this doesn't necessarily mean that he's not moving just because it's horizontal. Just because if you look to your left, he's actually moving 3 miles an hour there. So he is moving. So don't confuse distance and speed in that aspect. Where is he not moving? Only at the very beginning, which makes Make sense? And at the very end. Basically, wherever the graph hits the x-axis, because that's where speed, or his movement, is equal to 0. Okay, and now we're going to identify the points where he was moving at a constant speed. So where was his speed not changing? Where did he keep the same pace for a little while? This is where we're looking for horizontal lines. Okay, right here, it consistently stayed 3 miles an hour. This section right here, this section right here, here, and all for the same reasons. The horizontal lines stay at the same pace. Any positive or negative slopes represent a change in speed. Okay, and number 3 is very similar to the question we worked on the first slide, the greatest acceleration or deceleration. Again, we're looking at slope. Okay, in this case, the slope represents the rate of change in your speed, which is a fancy word for acceleration, or if you're slowing down, deceleration. So which area has the greatest slope? Just doing rise over run just to save some time here, we can see the first segment is going to be 3 over 2. We have 2 over 2, which would be 1. Okay, we have 1 again, down 2 over 2. This is going to be 1. This is going to be up 1, 2, 3, 4 over 2. And most obvious one here, we can see you're dropping 8 units and over 1. That would be our steepest slope. So in this interval right here, so we call it from 19 to 20 seconds. So they'll have the greatest deceleration rate. His speed was changing the greatest from 19 to 20 seconds. You can see that rapid change. He went from 8 miles an hour to almost a dead stop. Okay, and I was kind of rushing through the calculations there, but you could do it a little bit more in detail with actually calculating the slope in each case. But again, just remember with slope, rise over run, or change in y and change in x. Okay, and one last thing to consider for the quiz, creating your own kind of fictional story or writing a few sentences based on a graph. So in this case, I have a distance graph. We have a few things going on. I'm just going to label what could possibly be happening. Obviously, there's a million ways to interpret this. There's no right or wrong answers. There are right or wrong answers, but there's no specific right answer. If it fits, it's fine. Okay, so in this case, I'm going to say this person is traveling to the library, let's say. So A represents this person driving their car at a constant speed. Now in B, we have a horizontal line, meaning distance doesn't change. So if you're driving in your car, B represents something where you're stopped. So let's say you hit a stop sign or a red light, so you pause. C, we start back up again. See our distance is changing. Start driving again. D, we get to the library, we grab whatever books we have to get. Obviously your distance is going to be changing slightly, but in the grand scheme of things, you're at the same building, you're not really moving, you're at the same location. So that makes sense that your distance would stay the same. And E, we go straight back to our house. So let's say you catch every red light. Hopefully you're not going through any stop signs or breaking any laws, but drive straight home. You're not pausing at all. Okay, so this is a quick example. Obviously you can do it in a little bit more detail, you can be more imaginative, but that's an example of creating a function story based on a graph. Okay, thanks for watching, guys. Hopefully all this information helps. If you have any further questions, be sure to let me know, and thank you.